Good day, everyone. It is nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel. In this particular episode of our crash mathematics for SS3, we are going to be dealing with your measures of dispersion. And these measures of dispersion, they are known as your measures such as your standard deviation, variance, your mean deviation, your range, and so on and so forth. Now, in this particular video, we are going to be demonstrating how to calculate your standard deviation, your mean and your mean deviation, and your variance, so using different techniques. So and then in the first part of this video, let's talk about the standard deviation. Now the standard deviation is the square root of the variance, just in case you don't know. And in this video is going to be demonstrating how to calculate your standard deviation using two different methods. Now your first technique is given a set of n numbers with mean m. The deviation d of each number x from the mean is x minus m. So and then also we have the sum of deviations is written as summation open bracket x minus m, where summation is produced sigma. So that e, which is like an inverted e, is produced sigma. You can also call it summation. So it is sigma x minus m, and it stands for the sum of, if all the deviations are added together, their sum is 0. So that is summation, or sigma d is 0. You can also say sigma open bracket x minus m is equal to 0. So there are different steps for calculating the standard deviation, and they are: the step 1, you calculate the mean first. Then the next step is to find the deviation of each number from the mean, and the third step is to square the deviation. The fourth step is to obtain the mean of the squares of the deviation. Then the fifth step is to find the positive square root of the mean obtained in step 4. Now, as you can see in this example, our standard deviation is equal to the square root of the summation, the square of the summation of the square of deviation divided by the number of data. So as you can see in this example, we have that summation open, that's square root of sigma open bracket x minus m close bracket square divided by n. That is the way you represent the standard deviation. Now we are going to be moving next to calculation in this concept. So that would be I'll give an example. And this example 1, we have the scores in history of 9 students are 60, 75, 66, 84, 59, 74, 48, 56, and 90. Now we are looking for the mean. That's the first part of the question, which is alphabet A. Then B, we have the standard deviation. So we are looking for the mean and the standard deviation. Now this is how it's done. Now the mean is equals to the summation of scores divided by the number of scores, right? So you still remember the formula for mean from your junior school and all the rest from your earlier education in mathematics. Now that means that implies that we are going to add up the numbers. So as you can see, when we add the numbers, that will be 60 plus 75 plus 66 plus 84 plus 59 plus 74 plus 48 plus 56 plus 90. Then divide that sum by 9, which is the number of scores. So at the end of the day, we have our sum as 612 divided by the number of scores, which is 9. 612 divided by 9, that's 68. So finally our mean is 68. Now moving on to the next part, we have we have to find the standard deviation. Now we are going to follow the steps. You can see that our first step is to calculate the mean, right, which we've done already. Now the next step to follow is to find the deviation of each number from the mean. So we are going to subtract the mean from each number in the data. So that means our mean is 68, right? So we are going to subtract 68 from 60 to get minus 8. Subtract 68 from 75, which will give us 7. Subtract 68 from 66 gives us minus 2. Subtract 68 from 84 gives us 16. Subtracting 68 from 59 gives us minus 9. Subtracting 58 from 74 gives us 6. Subtracting 58 from 48 gives us minus 20. Subtracting 58 from 56 gives us minus 12. Subtracting 68 from 90 gives us 22. So these subtractions gives us the total deviation, and then when we add all this, we get the sigma of deviation, or the summation of deviation. So and then the total of deviation which is the total of the square of division. So when we square it on the table, we have to square it in the third column of this table. As you can see, when we square it, we have the respective square of each of the scores, and then at the end of the day, when we sum those squares together, we have the summation of the or the sum of the squares. That is the total of 1518. So and then our standard deviation is gotten by looking for the square root of the quotient of this sum by and the number of data. So that will divide by 9. So 9 is the number of data. So that will be our standard deviation will be equal to the square root of 1518 divided by 9. That would be 13. So finally we have a standard deviation of 13. Now let me add here that when you square your answer, you will get what is known as your variance. So this your variance is also known as the square of your standard deviation. That is like the square of the deviations called your variance. Now let's move on to the next part of this video. So in this next part, let's talk about the next part. That would be variation. Now in this I'll give another example, and in this example we're talking about variation. And in this variation, it is just like your standard deviation, but we are going to be given the square of the standard deviation. So we are going to be squaring it up. So now in this example, let's calculate this. Now we have the score in a spelling test for a class of 32 students are given in table 12.2. Now in this table we are given the scores from 0 to 5, and we are given the frequency of these scores. Now the score and the frequency. The score is basically the marks, and the frequency is the number of times each of those scores appear in the distribution or the data. Now in this table we are asked to, number A, we are asked to calculate the mean score. Number B, we are also asked to calculate the standard deviation of the scores. Now if we are looking for the standard deviation, now the mean score, we will use the same method as the previous example. In this case, we are going to write the scores down with the frequency, and then we are going to multiply the frequency by the scores, which is fx. That will be 0. For that's in the third column. When you multiply them, all of them. So when you multiply in the third column, that will be 0 times 3 is 0. 1 times 4 is 4. You will get the product of the frequency and the scores in the third column. Then the fourth column, you are going to look for the deviations for the mean. So the mean, we've already calculated the mean below that table as summation of or sigma fx over sigma f. That would be 96 divided by 32. That's 3. So from the table, that's what we've calculated so far. And then the next part of this question is we are going to be making use of the deviation from the mean. So that's the square root of that will be for the standard deviation. When we look for the square root of sigma f d square over sigma f, so that would be the expression for standard deviation. So now from the table, when you look for d is basically when you subtract the mean from each score. So that means the mean of 3, when you subtract from 0, you give minus 3. When you subtract the mean of 3 from 1, you give minus 2. When you subtract the mean of 3 from 2, we give minus 1. Subtracting the mean of 3 from 3, we give 0, and so on and so forth. So that's the fourth column of the table. Now for the fifth column, we will square the result. So in the fifth column, we square all the deviations. Then in the sixth column, we multiply the frequency by the deviations. So that will give us the final column which we will use to calculate our standard deviation. So our standard deviation is given by the square root of our answers, our total in the last column, which is 84, divided by the total in the frequency column, which is 32. That's the square root of 84 divided by 32. That would be 1.6. Now this is another example that I'm using to demonstrate standard deviation. Now let's move on to the next part of this question. So now in the next part of this question, let's talk about the summation of these deviations. In example 2 and 3, the sum of f d square is given as is used to calculate the standard deviation, right? Now, but in this particular case, we are going to be making use of the sum of f d square is written as summation f d square. That's also known as sigma f d square. Then next we have similarly summation fx or sigma fx means the sum of the products of frequencies and their corresponding values. So that is an explanation of what I've just demonstrated. Also, summation fx square means the sum of the products of the squares of values in a distribution and their corresponding frequencies. Now the formula used in example 2 and 3 can be written as s square equals sigma f open bracket x minus m close bracket squared divided by sigma f. Now where m is the mean and s is the standard deviation. An alternative formula is S square equals sigma fx square over sigma f minus m squared. Now in this case, this is an alternative formula for looking for the standard deviation, and then, or you can also write it as S square equals sigma fx square over sigma f minus sigma minus open bracket sigma fx over sigma f close bracket squared. So this is another alternative formula and method that we can use to look for the standard deviation or the variance, because as you can see, the standard deviation S is the square root of the variance, and the variance is the square of the standard deviation. Now, using this new method, we are going to be expressing that new method in a subsequent video, in a subsequent example. But let's move on to mean deviation, which is the next section of this video. Now, for mean deviation, it is just like standard deviation, but mean deviation involves using the mean or the absolute values. So now let me demonstrate that. Now let's talk about that. The mean deviation we are going to be making use of, we are to find the standard deviation of a set of numbers. The deviation of numbers from the mean are squared to make the deviations positive. So all you need to do, you need to square the deviations. Another way of making the deviations positive is to ignore their signs. So when we ignore the signs of this deviation, it's also known as mean deviation. So if the signs of deviations are ignored and their mean is obtained, we obtain the mean deviation. And the mean deviation is another measure of the variation or dispersion of a set of numbers. The mean deviation is equals to sigma of the absolute value of x minus m, so divided by n, which is where x is the particular score, m is the mean, and then n is the number of data in the distribution. And where x is the number, m is the mean of the number, n is the total number of elements. So and then the absolute value of x minus m is the positive value of x minus m. So another word for absolute value is denoted as a positive value. So anytime you see it in anywhere, always know that the absolute value is another way of talking about the positive value. So for example, the absolute value of 2 is 2, the absolute value of minus 2 is 2. I like to see it like when you ignore the sign. So just ignore the sign and just write the ordinary value. That is another way of seeing absolute value. Now let's talk about a example which will help us to understand standard deviations, rather mean deviation more. And this example goes thus. Now in this example, we are given that find the mean deviation of this set of numbers. So we are looking for the mean deviation of 58, 59, 60, 62, 61, 65, 62, 61, 52, and 60. Now these are 10 numbers. We are looking for the mean deviation of these 10 numbers, and these 10 numbers form what is known as data. Now in this data, we have our mean as a summation of data divided by the number of data, which is when you sum everything together, you get 600 divided by the number of data is 10. Now when you evaluate that, you have your mean given as 60, so your mean is 60. Now when you set out the deviations, you set out the table. So now in this case, we are looking for the absolute values, right? So all we need to do now is we are going to make use of the absolute values here. So when we have the data out, we have we are going to subtract the mean from each of data. So 58 minus 60 is minus 2. 59 minus 60 is minus 1. 60 minus 60 is 0. 62 minus 62. 61 minus 60 is 1. 65 minus 60 is 5. So that is the deviations. So then in the third column of this table, what we are going to do is we are going to be discarding the signs. So we are going to be assuming everything is positive. That means for absolute value of minus 2 is 2. Absolute value of minus 1 is 1. Absolute value of 0 is 0. Absolute value of 2 is 2. Absolute value of 1 is 1. And so on and so forth. So at the end of the day, when we add up all those absolute value, or in other words, when we look for the sigma of or the sum of all those absolute values, at the end of the day we have 22. And so our mean deviation is equals to the division when you divide the sum of the absolute deviation by the number of data. So in this case, we have 22 divided by 10, that is 2.2. Now I hope this question is well understood by you. So let's move on to the next part of this video. Here we're talking about something else that will be a way of combining the two things we've talked about. So in this video, we've talked about the mean deviation and standard deviation, right? Now in the next part, let me give an example which combines the two together. Now in this example, this is example 11. Now let's talk about that. Now in this example 11, we have we're asked to calculate the mean and standard deviation of the distribution in table 12.26 using a working mean and the formula as given as s square equals summation or sigma fx squared over n minus m squared. Now the solution is presented in table 12.29, as you can see in the screen below. So in the screen beside me, you can see the solution of this example. So now in this case, we have this table. In the first column of this table, we have the intervals. Now these intervals are given as the classes. Now these classes, we have our data is given as a class of data. Now we have the first class. In the first column, we have the class of 151 to 156, 55. We have the second row as 156 to 160. We have the third row as 161 to 165. Now this is known as a class data, and this data is kind of like a group data. Now this is the procedure for looking for the mean and standard deviation of group data. Now in the first section of this video, I talked about on group data, right? Now in this is the procedure for group data. All you need to do is you look for the mean value. And in the previous episode of this course, I talked about the fact that the mean value is the same thing as the average of the limits of the class. So in this case, just in case you don't know that, let me explain that again. So now in this first class, we have our first value as 151, our class of 151 to 155, right? Now in this class, we have our upper value as 151, and we have our lower value as 155. So all you need to do is you are going to look for the average of these values. So these values are also known as the class values. So when we divide the sum by 2, that will be 151 plus 155 divided by 2. That would be give us 153 as the result. So that is going to be the average or the class value. Now in the second column, when we perform this process down, we'll have the average value or the class values of each of the data. Now moving on to the next part, all we need to do now is we are going to look for the deviation. So we are going to subtracting each of these we are going to subtracting an assumed mean from the each of these class values. So now in this third column, what we are doing here is we are going to pick a number. So for example, we pick 163. Now if you don't know how to make use of the working mean of to calculate the mean of data, this is how it's done. So the working mean is also known as an assumed mean. It's just like an arbitrary number which is taken, and then you are going to subtract that arbitrary number from each of the class values. So in this third column, we are subtracting 163, which is the arbitrary number, subtracting from, in the first row we are subtracting from 153. Now we subtract 163 from 153, gives us minus 10. We subtract 163 from 158, it gives us minus 5. Subtracting 163 from 163 gives 0. Subtracting 163 from 168 gives 5. Subtracting 163 from 173 gives 10. And finally, subtracting 163 from 178 gives 15. Now in this third column, we have, as it is, we have all the deviations. Now in the next part of this question, don't forget that in this question we are looking for the mean and the standard deviation, right? So in the next column we are going to write down the frequencies. Now these are the frequencies of the data. So and the total frequency is 40. Then next we are going to look for the product of the frequency and the deviations. So let me remind you that in standard deviation you do not look for the absolute value of the deviations. All you need to do is you look for the squares of the deviation. So now in this case, where we are making use of standard deviation, we will make use of the square. In the fifth column, we are using the product of the frequency and the deviations, and the reason is that we want to look for the value of the mean. So when we look for that, we also have in the sixth column we are going to square the deviations, and we'll make use of that to calculate the standard deviation. In the seventh column, we'll make use of the product of the frequency and the square of the deviations. So at the end of the day, when we sum everything up, we have our mean is given as the sum of our assumed mean and the deviation, the sum of the deviation divided by the number of data. So that's 163 plus 235 divided by 40, and that will be equal to 168.9. That will be our mean. And then finally we'll make use of this to look for the standard deviation. So in this case, we are given as in the question asks us to use the formula that s squared equals summation or sigma f x squared divided by n minus m squared. So m is the mean, n is the number of data, sigma is the summation or sum of data, and then f is the frequency of each of the classes, and then your x is the average value of each class. So when you plug in the values of our mean, of our number of data, of our average values, and of our frequencies, we'll get our standard deviation as equals to the square root of 2775 divided by 40 minus 235 divided by 40 squared. That would give us, finally, at the end of the day, we'll have a value of 5.7 as our standard deviation. So finally, this example is meant to be a wrap up of the principles I talked about in this video. And now in this video, to sum up, we'll talk about the mean deviation, the mean calculation of the mean using the normal method and using of the assumed mean method. Then I gave you one method of solving the mean deviation, and I said the mean deviation is the deviation of the data from the mean that is calculated, ignoring the point, or rather the signs of those data, now of those deviations. Then but the standard deviation is making use of the square of those deviations, the sum of the square of those divisions, and you are going to look for the square root of that of the average value of the square of those deviations. That is known as standard deviation. Now this is where we'll get to in this video. Thank you for watching and see you next episode.